We tend to assume that building serious muscle requires serious equipment, heavy steel, complex machines, and racks of dumbbells. But if you strip away the commercial facility and look closely at a person dropping into a push-up on their living room floor, you are looking at the same fundamental physical process. Your central nervous system cannot read the numbers stamped on the side of a weight plate. It doesn't know whether you are pushing against a calibrated barbell or the ground beneath you. It only speaks the language of mechanical tension, the force generated when muscle fibers are stretched and contracted against resistance. This diagram maps the primary pressing mechanics of a standard bench press. As the model rotates 90 degrees forward into a push-up position, the primary vector of resistance remains the same. While a push-up allows the shoulder blades to move more freely than a bench press, the horizontal abduction and elbow extension required of the chest and triceps are functionally equivalent. The real divergence between the two isn't the quality of the movement, but the ease of progression. In a gym, you can infinitely add 5-pound plates to a barbell to keep that mechanical tension high. Your body weight, however, is a fixed variable. Because your weight remains static, standard floor push-ups eventually hit a ceiling. Once your muscles adapt to moving that specific percentage of your mass, the stimulus for new growth disappears. To continue driving hypertrophy without adding iron, you have to change how your body interacts with gravity. The most direct way to bypass a plateau is to increase your total mass. Wearing a backpack loaded with books forces your muscles to adapt to a new threshold of resistance. But the more sophisticated tool is leverage. By altering the geometry of your posture, you can shift your center of mass to force specific muscle groups to carry a significantly higher percentage of the weight you already have. This vector graph analyzes the load distribution of a baseline push-up. The upper body supports 65% of your total mass. Elevating the feet into a decline reaches 80%. Transitioning to a single arm focus condenses resistance, pressing nearly 100% of your weight. By treating the skeleton as a geometric lever, you can increase the mechanical tension on the chest by over 50% compared to the baseline. You are making your existing weight feel heavier simply by changing the angle of the press. Mechanical tension is the primary signal for growth, but it works in tandem with metabolic stress. To force the body to rebuild, you have to exhaust the muscle fibers beyond what pure weight alone can achieve. Slowing down the tempo is the simplest way to reach this state. By eliminating momentum during the descent, you maximize the time under tension, stripping the muscle of any momentary rest and forcing it to work continuously through the entire range of motion. You can amplify this stress by removing physical stability. Placing your hands on sliders, towels, or gymnastic rings removes the friction of the floor, forcing the chest to work overtime just to keep the arms from sliding outward.
This creates an intense neurological demand, bypassing the fixed paths of standard gym machines. You can see the visible shaking as the deep stabilizer muscles are forced to fire in overdrive to maintain control of the movement. Adding kinetic instability generates a level of metabolic stress that matches heavy external weights. It builds a more resilient neurological connection by teaching the brain to coordinate multiple muscle groups under extreme tension. Even with advanced leverage, horizontal training has a structural limit. The floor acts as a physical barrier that prevents you from reaching the full downward stretch of the chest and shoulders. To bypass this, you must introduce verticality. Transitioning to a dip, using parallel bars or even the edges of two sturdy chairs, allows the body to move through a three-dimensional space that a flat floor cannot provide. This diagram compares the two ranges of motion. The push-up stops at the floor, while the dip allows the torso to travel deep below the baseline. This stretch places the pectoralis under heavy load at its longest length, triggering muscle fiber repair. Developing strength at this maximum range of motion provides the mechanical foundation for explosive pressing power. By training the muscle at its most vulnerable point, you ensure it is strong across the entire movement. Moving off the floor and into vertical space fulfills the final mechanical requirement for hypertrophy. You have maximized the tension, the metabolic stress, and now the range of motion. When you combine these hacks, leverage, slow tempos, and vertical depth, into a single session, the physiological demand becomes extreme. Your body's energy stores deplete rapidly. The demand for oxygen in the working muscle fibers begins to outpace what your cardiovascular system can provide, creating a localized environment of intense chemical stress. This leads to the point of absolute mechanical failure, the moment your central nervous system physically refuses to complete another rep. This isn't just fatigue, it is a total biological shutdown of the motor units. Reaching this threshold proves the effectiveness of the system. It demonstrates that your own internal mass, when manipulated correctly, is sufficient to trigger the body's emergency growth response. However, the workout itself is merely a catalyst for destruction. No new muscle is actually built while you are moving. The actual physiological adaptation, the synthesis of protein and the thickening of the muscle fibers, takes place during recovery. This diagram shows the cellular repair process that occurs strictly during rest and deep sleep. When that repair cycle is complete, the resulting muscle tissue is biologically identical to the tissue built by a person lifting heavy iron. The body does not distinguish between a barbell and a well-leveraged dip. It only responds to the stress it was forced to overcome. True strength is not dependent on a specific facility or expensive tools. Once you understand how to manipulate gravity and leverage, you realize the only gym you ever needed was the body you were born with.